So today we get to talk about vector subtraction. Excellent. I will tell you this, vector subtraction is, how shall I put this? Well, it's one of those things that's so easy, I think it's hard. The hardest part about vector subtraction is the setup and recognizing that it's subtraction. And I will tell you this, it gets easier in grade 12, and it gets easier in grade 12 because of what I do in grade 11. So don't freak out if you don't get it first try. Okay? Perfectly 100% normal. Let me just remind you first of all about what vector addition looks like. Okay? And basically vector addition looks pretty simple. We simply put the vectors tip to tail, right? Tip to tail. And I think for the most part, everyone's on a scale of say 1 to 5, everyone's in the 3, 4, or 5 range. I don't think there's anyone still at a 0 or 1. I understand. You will right away. For now, you just need to listen. Okay? So, knowing that vector addition is tip to tail, what is your gut instinct telling you about vector subtraction? And go right ahead and yell it out because they're probably, don't worry about being wrong. Because there's no one in here that probably knows. What do you think vector subtraction would involve? Anybody want to take a wild guess?
Tail to
tail. Tail to tail. Okay. Possibly. Anybody else? Leroy, what do you think? Do you think it has something to do with the order, how you put them together? That certainly feels like it should, right? Okay, so we've got tail to tip as a suggestion. I was going to call you Ben, but I won't. Alex? I didn't.
I don't know.
Oh. Got a garden nose speaking back there. Anybody? Anybody? Subtraction of vectors. What do you think, Sean? Come on, you've always got something wise to say.
Subtracting 2 vectors?
What does that mean? Okay, well, if we look at regular numbers, regular plain old numbers, let's just pick, I don't know, 8 minus 4 compared to 8 plus 4. Think about just regular numbers. 8 plus 4 means you take 8, and you add 4 more, you get 12. Subtraction means you got 8, you take away 4. Can you convert that to a vector with direction? Maybe. But I will tell you this. You can write this down. Would you agree that subtraction of scalar numbers can be rewritten as addition? Every subtraction question you've ever seen, I can turn into an addition question. If I go 10 minus 6, well, that's simply 10 plus a minus 6. Does that make sense, Tristan? There's no addition question you can give me that I can't flip it, or sorry, no subtraction question you can't give me that I can't make into addition. And we might say that negative 6 is simply the negative of plus 6. Will the same thing hold true for vectors? Will the same concept hold true? And the answer to that is yes. But then the question arises is, what does it mean to take the negative of a vector? That would be a good question if you were to ask that. What does it mean to take the negative of a vector? All right, I've given you a chance to think. What do you think I'm going to pick on Cody? Cody, what do you think it means to take the negative of a vector? I don't know. It's not a hard, the answer's not hard. I understand you might not get it, but it's not something crazy complicated.
Switch directions?
Switch directions, says Sean. Okay, what do you think, Si? Does that seem like a reasonable thing to do? Take the negative of the vector? So what Sean is saying is if the vector is north, the opposite of that would be? Does that not make pretty good sense? It does. In fact, that is the correct answer. Okay, very good, Sean. Okay? So, subtraction of vectors can be done in the same way, and the question that we asked is, what is the negative of a vector? Does anyone need to write that question down? Do you need to write down the answer in italics? That's the important part, isn't it? Or can you just know it? Do you think you need to write it down? Are you ever going to read it again and go, oh yeah, I forgot that? Or is that going to be one of those things that you just know how to do by the end of the day? The negative of a vector is a vector having the same magnitude, which means the same length, but exactly the opposite direction. Exactly the opposite direction. And that, I wouldn't say that's the hard part, but that's a little bit of the trickier part. Now you'll notice that I have some clicker questions here. Regrettably, this computer that I'm running does not have the clicker stuff installed. And yesterday I got it all installed by just unplugging everything, and it was about a 10-minute job, and I forgot I had clicker stuff today, so we're going to have to do it without it. What is the negative of 10 meters per second east? 10 meters per second west. Now, would it be minus 10 west, or would it be 10 west east? 10 west, right. B is the correct answer. Okay, so it's not hard. It's simply exactly the opposite direction. East becomes west, north becomes south, and so on. What about something crazy? Let me just look ahead here for a second. What about something crazy like, oh, I don't know, east 40 south? What would that become? East 40 south. Well, east 40 south would be east, and then it would be like this, right? So the exact opposite direction would be like that, and I think it doesn't take too much to realize that that would be simply west 40 north, right? That make sense? Does the number always stay the same? The number always stays the same. East becomes the west, and the south becomes north, and you just carry on from there. Okay? You just carry on from there. So, we're almost done, basically. To subtract vectors, and this is the key, find the inverse, the opposite, of the vector to be subtracted, and simply add it tip to tail to the other vector. In other words, just add the opposite. That's what it boils down to. Add the opposite. The question is, what if there's more than two vectors? In other words, like what if you've got something like A minus B minus C? Well, then that would simply be A plus minus B plus minus C. So which ones would you flip? The B and the C, and then you would just simply add them to the tip, right? No worries. Not likely ever going to see that, actually. Possibly, I suppose. Okay? So yeah, in grade 11, I'm going to pretty much tell you, do this vector subtraction. When we move more into grade 12, you have to recognize more that it's a vector subtraction. There will be some where you have to do some recognition, but that's basically it. Can you flip it and then add? That's what it really boils down to. Okay? So, let me give you an example here. I've got A minus B. So if I've got vector A like this, right? And vector B straight up like that, well, what is minus B equal to? Straight down, right? And then you simply add them. So it's going to be A, and then you add tip to tail minus B. Now, I have yet to find, you know how in regular math, when you add two numbers, they call it the sum. When you subtract two numbers, they call it the difference, right? When you add two vectors, we call it the result. When we subtract two vectors, I've yet to find a proper word for it. So we'll just call it the result. I haven't been able to find a different word for that. So, does that make sense? When I drew that? So quiet. Scary. Okay, well, jot that little sample one down. Okay, so some of you might have actually started with that. I don't know. A is 10 meters north. Let's draw it like this. Let's go 10 meters north. Vector A. Vector B is 15 meters east. So what does that make minus B equal to? 15 meters west. And then how do I add them? I'm going to go A plus minus B. So I don't add the black one, I add the red one. And I go like this. So this vector, subtract that one. This one, take away that one, is equal to that one there. That's my result. Minus 10. Ooh, no, not minus 10. Maybe I'll say minus B instead. Now, do I do anything special with finding the result? No, because all it is become now is a what kind of question? Plain old addition. I just do what I've been doing all along. The only thing that's different is I take the second vector, the one that I'm subtracting, and flip it. That's all you do. Just flip the subtraction. Okay? Now, is that a right triangle? It is. Okay, so that means I can use Pythagoras. I don't have to use my protractor. So I'm going to write r squared is equal to 10 squared plus 15 squared. Now, here's a question that some kids ask me. Do I have to put that 15? Do I need to put that as minus 15? Why not? Why no? Say it again, mate. We only change the direction on the direction, right? Like the length. Pythagoras is simply a geometrical equation for when you've got 15. Does Pythagoras care whether it's left, right, up, down? It's just a length, right? So we're just using a tool to find the length of that. So really, and even if you did care, minus 15 squared is going to be exactly the same thing. So it really doesn't matter. So r squared is going to be 100 plus 15 squared is 225, and so r is the square root of 325. And I should probably know that answer. 100 and, is it 180? No, it can't be 180. 18. Wait. 18 meters. Am I done? Done, Mitchell? Very good. Got to find the angle. How come? It's a vector, right? Got to find the angle because it's a vector. And remember, we always measure from where we start. Do I actually have to use a protractor here, or can I actually use something else? I can use grade 9 trigonometry because it's a right angle. And so I'm simply going to write theta is equal to inverse tan, opposite over adjacent. The opposite is the B. The B was the 15, I believe. The A was the 10. And so I've got theta equals inverse tan, 15 over 10, and I get an angle of 56. And we're just going to leave all our angles at 1 decimal place. There's 0 decimal places. And now that's going to be, what's going to be the letters that go with that angle, 56? That's going to be north, 56, west. Right? North, 56, west. If I were marking that, I would give you 1 mark for the angle. I'd give you 1 mark for the 18. And I'd give you 1 mark for doing the flipping as well. Okay? For recognizing its vector subtraction. 1 mark for the flipping. If I was generous that day, I might be giving up 1 mark for the diagram. But that's sort of built into that flipping too. Okay? Alrighty. Tell me here. It would be nice for you to jot that down, but I understand it. Take a second or two. Vector A is 5 meters north. Vector B is 4 meters west. Which diagram best shows A minus B? Which one best shows A minus B? You say C? Alex? C. Lloyd, what do you say? You're with C? Anyone want to say anything different than C? Everyone's a pirate today.
You hear my funny joke?
No, it's a funny joke. All right, so which one do you think it's C? So I got 5 meters north, 4 meters west would be to the left, but I want to go change that west to east. Yeah, C it is. C it is. Good? Who said this vector subtraction was hard? All right. That's the main idea of vector subtraction. What's it going to do? Well, displacement. Let's go back a little bit here and let's talk about displacement flat. This is where it starts to get confusing, but it's one of those simple things that we've just made confusing. But I'm going to try to make it as simple as I can. An object got a number line at an initial position of +3. It ends up at a final position of -3. Find its displacement. You don't need to write this down. I'm just building some building blocks here, okay? I'm going to start here at +3, and I'm going to end up at -3. I'm going to call this my initial position. I'm going to use X for position. And I'm going to call this my final position. This is my displacement. How far did I go with it? What direction? -6, right? No one needs any calculator or anything like that to figure this out. I can tell. You can just count if you want. I went 6 to the left. -6. Okay. What's this got to do with vector subtraction? I'm going to take that one-dimensional thing there, and I'm going to turn it into a two-dimensional vector question. You'll notice here, I've got delta D is final position minus initial position. That is also true even if it's 2 dimensions. This is a 1D situation, right? Left or right. What if it's a 2D situation? Is displacement final position minus initial position? Absolutely, right? Think about 2D surface here in the room. Can you imagine the big axis right down the middle? Another one this way, right? So 0, 0 is right in the middle there. Right? I'm at the origin, 0, 0 right here in the middle. And if I start over here by the door, and this is my initial position, and I two-dimensionally walk, I don't know, back to the back of the room, stand here behind Connor, what's my displacement? Over from the door to here. Final position minus my initial position. This vector there, right to the door, would be my displacement. Let's draw that. Okay? And it is vector subtraction. Okay. So I'm going to use, oh, I've zoomed in quite a bit here. Here's my example. A hunter is at an original position of 500 meters east from his truck. He walks for a while and ends up 750 meters north of his truck. What was his displacement? Jot that down, because we're going to do this example. What's the truck there for? Yeah, well, what's the origin? Really good shot. The truck is the origin. It's my reference point, we might say, too, right? This is my origin. It's my 0, 0. It's my origin. Okay. So a hunter is at an original position of 500 meters east from his truck. So he is standing right there. Did he walk from his truck to there? Maybe he was somewhere else. Maybe he got dropped off there. Maybe he was abducted by aliens and dropped in the field right there. We have no idea. Do we care? No. The truck is simply the origin. It could be a tree that he was 500 meters east from. It doesn't matter. The truck is simply the origin. Did he go from there to there? Don't know, don't care. Doesn't have anything to do with the question. I get people that worry about that. Okay? Doesn't matter. That is his position. Okay. Now, I just drew an arrow and then I erased it. But I'm going to draw it again. Does that mean that he walked from his truck to there? No. This is simply a vector showing where he is in relation to his truck. It's a vector showing his position relative to his truck. Okay. Then he walks for a while and he ends up 750 meters north of his truck, which of course is way up here. Did he walk from his truck to there? No. In fact, where's the one place that we do know that he walked? We know he walked from there to there, don't we? This blue one is his final position. It's simply a vector showing his position relative to his truck at some point in time. Did he walk along that blue line? No, he did not. Did he walk along that black dotted line? Yes, he did. And that blue dotted line is his displacement. Right? And it's important that I sort of set that all up. And it's okay if you don't get 100%. Okay. Now, most of you can say, well, I can solve that. That's just a triangle. I can solve that, right? But it doesn't show that you understand vector subtraction, and that's what's important, okay? So I'm going to show you something. You can say, that's stupid. I don't know why we would do that. But it's showing your understanding of vector subtraction. That's what's important. And when we get to grade 12, it'll all make a little bit more sense for you, too. Okay, so I'm going to write up here, and I hope you guys have left yourself a little bit of space. I should have told you. I'm going to write it inside the triangle because I can't use that space for much else. I'm going to write delta D is final minus initial. And then I'm going to write underneath that XF plus minus XI. All I've done is I've taken that vector subtraction and turned it into vector addition. And now can you draw this out? It doesn't need to be to scale because it's a east and north kind of thing. So I'm going to write XF. There's my XF. And I'm going to subtract my initial. My initial is to the east. So what's the negative of that? To the west, right? To the west. So I'm going to add tip to tail. I'm going to write minus xi. Did he walk along this black line? Did he go like this? And then did he go like that? No. Those aren't walking trails. Those are position vectors that show relative to some truck somewhere. Okay? He did not walk along them. The only place he walked, and I should have made them the same color, shouldn't I? Let's make them the same color. Blue. Okay, and so his result, his displacement is from there to there. How can I solve that? Now it's simply a vector addition question, and you can solve it the way I've been showing you for a couple days. So now you would just simply write d squared is 500 squared plus 750 squared, and solve for d, which I know you can all do. It's 901. 901 meters. Now, could I have not just written 500 squared plus 750 squared based on this triangle here? Absolutely. Absolutely I could have. Would it have shown me that you understand vector subtraction? No. So, you get 1 mark for that diagram, because that tells me, Mr. Bennett, I get vector subtraction. This tells me that you get how to do Pythagoras. And now what angle do I measure? Should I be measuring one in here? Probably not. We should be measuring that one right there. Is that a right triangle? Absolutely it is. Can I just go theta equals tan minus 1, opposite over adjacent. Opposite is the xi, that's like 500, 750, and I get an angle of 34 degrees. This angle here is 34 degrees. What letters go with that 34? Well, this is measured from north, so it's north 34, and I'm going to the left, which is west, right? There's my second answer. Second half my answer. Okay? So I know, have I made it way more complicated than it needs to be? Absolutely I have, and I will not argue with you over that. Mr. Rand, you weighed it way harder than it needs to be. I get that. Okay? But the point is not, can you get the answer? The point is, can you show me that you understand vector subtraction, so that in the future, when I give you harder vector subtraction questions, you can do it. That's the point. Okay? So you would see 1 mark for the diagram, the flip. You'd see 1 mark for the 901 and 1 mark for that. Fair enough? Yeah? You guys have been pretty attentive today. What have I got left here? Oh. Okay. I see what I've got here. All right. So here's my question. A hiker is 1.5 kilometers east from a campsite, then walks for a while and ends up 6 kilometers south of the campsite. What is her displacement? Which diagram best shows vector subtraction needed to solve this problem? So east, is that the initial or is that the final position? A hiker is 1.5 kilometers east from a campsite and then walks and ends up 0.6 kilometers south of the campsite. Which one's the initial? The 1.5 or the 6? The 1.5. Good. This one is the initial. This one is the final. Which one do I have to flip? If you get a little confused, that's okay. I even have to, when I'm doing an answer key, I will even write delta D is XF minus XI. I'll write that down. And then I go, okay, I know what this means. It means XF plus minus XI. So which one do I have to flip? The 1.5 east. I got to show the south one first, and then I got to go, not east, I got to go west. So which one shows south and then west? South and west. What's wrong with this one? This one is east and then north, right? That's the wrong flip, isn't it? Do you think I might do something like that? Put like a multiple choice question and have like the wrong flip in there?
No.
That's what teachers do, right?
I don't get it.
Okay.
If you're flipping the east, wouldn't you still go west first and then south?
You flip the initial one, right?
Yeah.
And it goes at the end. Now, I think what you're really asking me is, does it matter if I go south and then east, or south and then west? Can I go west and then can I go south? Is that what you're saying? Maybe. Technically, that's correct because I mean, vector addition doesn't matter the order, right? It's just that it doesn't really sort of match with the order of this. That's all. You're not technically wrong. It's just not maybe the best. Is that a fair answer?
Yeah.
Okay. Like I'm not going to mark it wrong, but I might say wrong order in quotations, but there is no wrong order. It's just not kind of what feels right. Okay. All right. So why don't you try that one? Do you need to write every word down there? Could you just write, if you're doing this as a sample question, could you just write xi equals 1.5 east, and could you write xf is 0.6 south? Would that be any shorthand version of that question? And we are solving for delta D. By the way, I'm going to ask you for the displacement and the angle. So I'll give you 5 minutes to do that, and then we'll check that. I'm just going to draw this out. So we've got east, and then we've got south, right? So this is the initial. The final is south. Flip the initial, so it's going to be XF. And then flip it, so instead of east, it's going to be west. I realize you guys can't do this, but I'm going to, oh, maybe I'm not. This is minus xi. There's our 1 mark there for showing vector subtraction. And now I'm just going to write r squared equals. Does it matter what order I put things in here? I'm not going to check. I mean, you probably should put the xf first, but I mean, really, who cares? I don't. So I guess technically it'd be 0.6 squared plus 1.5 squared. And what did you get for an r value? 1.6? Okay. 1.6, and then I need an angle, right? So that would be inverse tan opposite over adjacent. That's going to be 1.5 over 0.6 and 68. And that's going to be, now did I do something wrong here? Because that doesn't match my notes here. Did I do something wrong? I don't know. This is the initial, the 1.5 east. This is right. This is the final match initial. No, looks good. Okay, so that's going to be south. What did we say? 68? south, 68 west. Yeah?
Yep.
Good? Good? Okay. I think the next page is simply what's the angle of displacement, and we've already got that. Okay. It's time for you to try some. I gave you a sheet there the other day. You'll remember there were 6 questions of addition at the top. There were 6 questions, I believe, of subtraction at the bottom. I've just handed out to you the detailed solutions for subtraction, okay? Exactly how to do it. There's no reason for saying, I don't get this, because you can copy out the solution. And by about question number 3, you'll go, okay, I'm starting to get it. Okay? So use those as a guide. I will tell you this. Tomorrow I'm going to give you a hand-in assignment that you won't get a lot of help on from me because it's an assessment. No. And then after that, tomorrow's Thursday, right?
Yeah.
We'll do a little bit of review on Friday.
Don't say test on Monday.
How about I just think of it?
Say test Tuesday.
Yeah, can we do test on Tuesday, test on Monday start?
So 20% of all tests suck? What about tests on Friday? So 40% of all tests suck.
Yeah.
What does having tests on the same day as another teacher also suck?
Yes.
Okay, so what are the increased chances if you're not allowed to have tests on Monday or Friday? So now you're telling me every test sucks.
Yeah.
On Tuesday.
We will reevaluate tomorrow, Friday, but good chance it's going to be Monday.
That's Tuesday.
I understand. I just wasn't there. Good chance Monday.